Recording.
Hi y'all, my name is Ms. Rivera.
And I'm Ms. Schoenfeld.
I'm Mr. McKinney.
So we are going to be doing our first lab of the year. We're trying to make this as good as we can considering the COVID circumstances, but let's go ahead.
This has the same effect as glasses does.
So this lab is about properties and changes of matter. So we're going to be looking at how matter changes and look at some of the properties of it. So the first thing we're going to do is we're going to look at what happens when we try to light a match. Okay. So I'm going to light this match and I'm going to light this candle. Notice that the candle right now is solid white wax. Okay, so I have my lit match. It's got a smell like phosphorus burning. It's that classic match smell. Try to let the wick catch here. You can see the wick is changing color. I'm going to put some water in this beaker here, and I'm going to let that match cool down in here instead of in the sink so that it can safely cool. So while we are looking at this candle burning, notice that the wax is changing from a solid state to a melted liquid state. As it continues to burn, that wax is going to eventually burn off. So it's going to change from being wax into carbon dioxide and other things. So we're just going to let that burn for a little bit and move on. Okay. What's the next part?
The top.
Okay.
Okay. So,
So,
all right. This is horrible. Okay. So now what we're gonna do, we're gonna take a piece of chalk and we're gonna grind it up with a mortar and pestle. If I can get it grounded up. This one's a lot harder than the green one.
yeah.
All right. So as you can see, it's kind of grounded up. And I'm going to gently guide it into my test tube. And y'all, I'm allowed to touch this. This is just chalk. So I've added a little bit in there. Do you think I should add more? No. And then here's my vinegar, acetic acid. And I'm going to use a pipette here to add it into my test tube. Okay. I can bring it up closer. So what you guys can see here, it's a little bit cloudy. Sorry, y'all, I'm shaking. But it's a little bit cloudy, which could be the chalk. But if you listen to it, which y'all guys can't hear because it's a video, there is some bubbles going on there. Okay, oh, there it is. Okay, there are some bubbles going on there. So that's gonna represent a chemical change. You guys can see the bubbles, little tiny bubbles in there.
All right, so for this next part of the experiment, we are going to be adding about 100 milliliters of water. I have a 250 milliliter beaker, so I'm just going to try to add it as close to that 100 milliliter mark as possible. All right, so add a little bit extra, that's okay. It'll just make it easier to see. Next, I'm going to take my starch and I'm going to add about a spoonful. Very specific measurements here. We're using the term about a lot. Okay. I can see that it is slowly dissolving. Actually, more quickly dissolving now. I'm going to try to stir it up to get it to dissolve a little bit faster. The thing I'm using right now is called a stirrer rod. It's made out of glass, so it's safe to use. This is forming like a thick paste almost inside. And it's turning a milky white color. I'm gonna add just a little bit more water because this is kind of thick. Okay. There we go. All right, so we have this milky white solution of cornstarch and water. Now, the cornstarch has not yet reacted with the water. It is just dissolved, okay? So it is just dissolved in there. If I boiled out the water or let it evaporate, the cornstarch would come back out. The next step is I'm gonna take some of this iodine, which is first aid antiseptic, and I'm gonna add a few drops to my mixture.
Note the color.
Notice that right now it's white, like a milky white color. And as I add my iodine, it turns a lovely violet color almost instantly. As soon as the iodine touched the water starch mixture, it turned into a very lovely violet, kind of like the color of blueberry juice. So definitely a different color than either the white that it started out as or the brown of the iodine. So iodine is a very brown liquid. This started out as milky white. So if we have white and brown coming together, would you expect purple?
The next step is that we're gonna take some Alka-Seltzer basically and put it into our water. Note your observations. Okay, and if y'all guys don't know what this is to help ease your stomach acid.
So like if you have heartburn, nausea, heartburn, indigestion, upset stomach.
Like your Pepto.
Yeah. Plop, plop, fizz, fizz.
I think you
And
can
now
hear
y'all
it.
guys you might be able to hear the bubbles. That cloudy substance, just like the other
With the chalk.
with the chalk, it got cloudy at first, and that's all the bubbles forming in there. Okay.
So all of those bubbles that are being released are carbon dioxide into the atmosphere. So that is a reaction going on between the Alka-Seltzer and the water to produce carbon dioxide. All right, so now we are going to look at the reaction between copper sulfate, CuSO4, and sodium hydroxide, NaOH. Sodium hydroxide is a common base that we use in chemistry. You'll see sodium hydroxide used a lot in chemistry labs. It's probably one of the most common alkaline substances that we have. So here I have a test tube that I'm going to be using, and I'm going to basically add 1 pipette of each sodium hydroxide and copper sulfate into this test tube and see what happens. I'm going to take my sodium hydroxide. I'm going to carefully unscrew the cap with one hand while holding the bottle down with the other hand. I'm going to take my pipette, squeeze the bulb, dip it into the solution, let go of the bulb to draw up the liquid. Then I'm going to squeeze into the test tube. I've put these paper towels down as sort of like a placemat so that the pipettes are not touching the desk directly. When you're done with the bottles, always make sure to cap it tightly so that it's not going to tip over and leak. I'm gonna do the same with copper sulfate. This one's getting kind of low, so I've got to tip it over. You can see that copper sulfate is this greenish color. And I want you to see what happens when I add it. So notice that I added two liquids together, but they're not very, well, liquidy. I'm swirling this thing pretty hard and it's not moving very much. If you look carefully, you can actually see some crystals forming inside. They're kind of like a slushy. All right, so that slushy is called a precipitate. It's when you get a solid or crystals forming from the mixture of two liquids. So you can kind of see the divide down here. It's kind of like this darker crystal color. Up here at the top, this is the part that hasn't quite solidified yet. But you can see there's definitely a divide right there in between the two. That's it. So notice how the color changed from that greenish color of the copper sulfate in the background to more of a blue teal color almost. If you look just above where the liquid stops, you can actually see some of those crystals forming on the side of the test tube. It looks like little chunks on the side.